Hormones are never in charge. All they do is communicate biochemistry from one tissue to another. Their abnormalities are never the root cause of anything. Now, hormones matter, it's just that they're never in charge. I'm not strictly against the use of exogenous hormones, just like I'm not strictly against the use of NSAIDs for debilitating pain, but I believe it is very rare that anyone who prescribes hormones first dives as deeply as they should into fixing a person's biochemistry. On that note, please note the disclaimer that I'm not a medical doctor and I cannot manage your hormones and do not manage your hormones based on anything that I say. Now, with that said, none of what I'm about to say is meant to detract from my empathy for those who are suffering, who are in emergencies, or who have serious goals that they either genuinely have no time or at least perceive that they have no time to solve the puzzles that I raise before they pursue those goals, like having a baby. But nevertheless, I'm now going to tell it like it is. So there's basically three reasons for hormones to be messed up. And this is a general rule. I'll give you some exceptions, but the exceptions are just the exceptions that prove the rule. So the rule is 3 reasons your hormones are messed up. You don't have the raw materials to make the hormone or to make something that's needed to regulate the hormone's production. So for example, you can't make thyroid hormone if you have no iodine. Number 2, your situation dictates that you should not make the hormones that you think you should make, meaning the hormones that your textbook says you should make or the ones that you wish you were making, in which case they're not actually messed up. For example, if you're too low in body fat, your brain correctly does not trust your energy stores to be sufficient to carry forth a pregnancy and then nourish a child after birth, so it will restrain your fertility. If you are too high in body fat, your brain will deduct the stress of carrying the extra body fat from its calculation of your energy abundance and will restrain your fertility. And you see that exactly that in the epidemiological literature, that underweight and overweight are both associated with infertility. You want a baby, so you see this as a problem, and your doctor uses a reality distortion filter known as medical diagnosis to view the issue, so diagnoses it as infertility. But the reality is your brain is actually correct in its judgment. The energy abundance wasn't there for the tasks that it needs to be there for. So the third possibility is that you've not solved the small number of highly unique idiosyncratic bottlenecks in your energy metabolism that everyone has. Your brain correctly deducts the unusable portion of the energy from its calculation of your energy abundance. For example, let's say you have an impairment in short chain fatty acid oxidation. You can use the first 2/3 of a fatty acid, but can't use the last third of the fatty acid. And so you eat 700 calories in a day as fat, but your brain correctly recognized that 300 of those calories were useless. So neither your caloric intake on paper or in your Chronometer app or your MyFitnessPal app, or your actual body fat that you see when you look in the mirror or on your DEXA scan, or that goes into your weight when you step on the scale, none of those things reflect what is actually available to invest in fertility and long-term improvements in your health. And you don't know that, but your brain does. Your brain correctly understands this and has adjusted your hormones accordingly. So it's just those 3 things. And the problem with stepping in with exogenous hormones to solve one of these 3 problems is that in the first of the 3 cases, all you're doing is lazily skipping over fixing a nutrient deficiency, and you need to fix the nutrient deficiency for other reasons. There's no nutrient that only optimizes your hormones. So if the nutrient's missing, that's why your hormones are messed up, you still have the nutrient deficiency if you put the hormones in. In fact, you might make it worse by increasing the metabolic rate and the demand for those nutrients that aren't there. And then in the second and third cases, you are arguing with your brain when your brain is so obviously right. This is like arguing with your spouse that you in fact are not out of money, and you will prove it to them by buying all the nice things that you can find in the world by just putting them on your credit card. Okay, so there are some exceptions to the rule. I can think of a few. You could have a tumor pressing against your pituitary, and that's making your pituitary secrete abnormal amounts of hormones. You could have a tumor that secretes its own hormones. So for example, there's catecholamine producing tumors that make adrenaline. In these cases, the problem is still biochemical. It's just that it's not the biochemistry I'm talking about that loops the hormones together. It's the biochemistry that led to the tumor. So it's kind of an exception to the rule. It's just more like it's a special case of the rule rather than an exception though. I'm going to delay incorporating menopause into my framework because honestly, I need to think about it more. So maybe that's an exception. And then finally, cognitive processes act as direct input. So these are kind of an exception. They're not an exception to the rule that hormones are never the cause of anything, or they're never the root cause of anything. But they are an exception to the fact that it's always biochemistry driving the hormones. So a belief can stimulate the release of cortisol as an example, but even cognitive processes are intimately intertwined with biochemistry of neural cells. And so it's really difficult to know whether what you need to be doing is working on mindset versus brain biochemistry. And so on a practical level, it's not really an exception to the rule, because on a practical level, you should be working on both. Because when you optimize your brain biochemistry, it's much easier to do the cognitive work and to get the results from it. And so if you work on both, then you know you're good. Okay, so those are the exceptions, or kind of exceptions. So let's get back to the rule. I'll give you an example, which is how leptin, insulin, and thyroid hormone interact. As I covered in lesson 23 of my energy metabolism course, insulin release is not a direct response to carbohydrate ingestion. Rather, it is primarily a response to ATP opening up potassium channels, and secondarily to overflow, technically in jargon called cataplerosis, of materials into and from going out of the citric acid cycle. Under normal circumstances, ATP production will be greatest in the pancreatic beta cell when carbohydrate intake exceeds what is needed to restore glycogen content in the liver. Then the excess over this makes its way into the general circulation, part of which goes to the pancreas. And the biochemistry of the pancreas is wired up so that glucose is the best source of ATP. Now, it's not the only source of ATP by any means, so any macronutrient is going to increase the ATP production of the pancreatic beta cell. It's just like glucose is going to do the best job of it. So abundant carbohydrate reaching the pancreas, because it's exceeded the need to replete the liver's glycogen storage, will be the primary thing increasing the ATP there. And then overfilling the citric acid cycle so that it outpours is into amplification signals for the insulin release. That's going to happen to the greatest extent when most of the remainder of the energy from the meal, besides the carbohydrate, is protein. Now, if you replace those things with fat, you diminish those effects. But if you add fat to the meal, then you're going to get even more insulin release, because the fat is going to increase the total amount of energy in the meal, and therefore the total amount of ATP in the pancreatic beta cell. And then it's also going to conserve glucose and protein to fill up and overfill the citric acid cycle, which leads to the amplification signals. Now, as covered in my zinc podcast, each 6 insulin molecules is in a granule connected by a zinc ion. And upon the release of the insulin, the zinc ions are released. Some of it goes to the pancreatic alpha cell and suppresses glucagon release. And some of it traverses into the target cells like the muscles, so that it increases the response to insulin there. So altogether, net, you have zinc acting in 2 areas to increase insulin sensitivity, because glucagon antagonizes many but not all of the actions of insulin. However, many amino acids, through mostly unknown mechanisms, part of it is glutamate acting the same way that it does in neurons on glutamate receptors, but there's many other mechanisms of many other amino acids, and they're not known very well. Many amino acids, through these unknown mechanisms, stimulate glucagon release, and this is thought to allow the protein to enhance insulin secretion, to get more insulin, bringing more amino acids into muscle cells, but without causing low blood sugar. Now, the conventional hypothalamic pituitary thyroidal axis says that the hypothalamus makes thyrotropin releasing hormone, or TRH, which acts on the pituitary to stimulate the release of thyroid stimulating hormone, or TSH, which then acts on the thyroid to produce thyroid hormone. However, insulin acts on thyroid alongside TSH to increase thyroid hormone production. It will increase thyroid hormone production independently. It will also synergize, or it will act additively with TSH. Leptin also stimulates the production of thyroid hormone, probably through its actions in the hypothalamus. While leptin is made by body fat, primarily in proportion to the amount of fat stored, its release is also stimulated by insulin. The action of leptin and insulin on the hypothalamus looks a lot like the actions of glucose on a pancreatic beta cell. So in the hypothalamus, energy status is signaled by ATP, just like it is in the pancreatic beta cell. And ATP carries out that signal by opening up potassium channels, and the inflow of potassium signals the abundance of energy. Leptin and insulin act on the hypothalamus to enhance the activity of ATP on the ATP-dependent potassium channels. And their actions are opposed by transcription factors that are elicited by stress. And that could be internal stress signaled by inflammation, and it could be external stress signaled by hormones such as cortisol. So the model that emerges from all of this is that leptin is primarily a signal of long-term energy stores. Insulin is primarily a signal of short-term energy stores. Cortisol is a signal of external stress. Inflammation is a signal of internal stress. Both stresses are demands on current energy stores, right? So cortisol and inflammation are bringing forward the perception of how much energy has to be spent. And the brain is saying, okay, we need energy now. It's basically increasing the time preference in economic terms of the energy expenditure. So it's saying we need to budget for current emergencies, and we need to take that out of the budget for long-term investments. Now, the hypothalamus is going to make a simple calculation of energy abundance that looks something like, in very simplified form, you have leptin plus insulin as one term, and then you multiply this by ATP because they're enhancing the ATP. So that then becomes another term with parentheses around it. So you've got leptin plus insulin, parentheses, times ATP, parentheses, minus, and then in your next set of parentheses, you have inflammation plus cortisol, right? So you have leptin plus insulin altogether times ATP is your energy budget, and your inflammation plus cortisol is subtracted from that as the energy that is needed for current emergencies. And what's left over is your term of energy abundance that reflects the energy available for long-term investments. And those include long-term investments in making you healthy so that you can have longevity and health span. And it includes fertility, which in humans is basically a 19-year event. Biologically, that's not really true, but it's longer term than just a pregnancy because it covers lactation as well as child rearing. Culturally, we've kind of expanded, 11-year-old businessman to 18-year-old, barely an adult, 22-year-old, barely an adult, but whatever. Anyway, so the energy abundance term dictates what's available for fertility and long-term investment. And then the target cells decide how to respond to these signals. So the liver, as the metabolic hub of the body, will largely dictate whether thyroid hormone should be activated or inactivated. And then the cells that are doing things, like the muscle cell, cannot, if it can't afford to comply with the signal of thyroid, insulin, and leptin, it won't. It will just make its own decision, right? The cell is listening to the signals that come from the rest of the body about what's available and what it would be nice if it could get in line to help do. But the cell then has to look at its own budget and has to say, can I do this? And if it can't, it says, sorry, someone else is gonna have to take that task, which is an entirely appropriate decision to not comply with the signals because it can't do so while maintaining its ideal state of health. And then this leads to resistance to the hormones in the standard hormone-centric view of medicine and endocrinology, which is sort of a silly view because it carries the assumption that the cell is supposed to respond to the hormone, it's like middle manager syndrome. You're like, why aren't my workers doing the right thing? I told them to get the project done by Friday. And instead of understanding the motivations of your employees, you're like, no, I said it was supposed to be done Friday and it's not. So there's worker resistance. So anyway, being underweight and underfed detracts from the energy supply half of the equation, while being overweight and overfed creates internal stress that adds to the energy demand side of the equation. And you could see reasons to point out specific needs for nutrients. For example, we obviously need zinc for this if insulin is literally made as a granule of 6 insulin molecules per zinc ion. And we obviously need iodine if there are 3 or 4 iodine atoms per molecule of thyroid hormone. And the fact that selenium reduces antithyroid antibodies in numerous human trials shows that it's also important. But these specific examples just betray the complexity behind them. So for example, that selenium reduces antithyroid antibodies suggests that Hashimoto's results from local stress within the thyroid gland rather than systemic stress signaled by cortisol and inflammation that would antagonize thyroid production at the level of the hypothalamus. So it's a local thyroid issue rather than a systemic issue signaled at the hypothalamus, coordinated there. But this stress is oxidative stress, and that's because making thyroid hormone involves the production of copious amounts of hydrogen peroxide to oxidize iodide to iodine to be able to add it to the thyroglobulin molecule. And so that means the entire antioxidant network is important, not just selenium. You have the trials on selenium, but it's not my fault, nor is it your thyroid's fault that they didn't do the trials on the other parts of the antioxidant network. And those are vitamin E, vitamin C, glutathione, which comes from protein, iron, copper, zinc, manganese. And then the antioxidant system depends on the pentose phosphate pathway. So you've got riboflavin, niacin in the connection to the pentose phosphate pathway via the glutathione reductase enzyme. And then you've got thiamine, calcium, and magnesium as important cofactors in the pentose phosphate pathway. And then glucose. All of those are part of the antioxidant network that are obviously important in Hashimoto's because they're important in protecting the thyroid gland from oxidative stress. And if you have these trials on selenium, then it just obviously follows from this that the rest of the antioxidant network and the thyroid gland should deserve equal weight. And then the centrality of ATP in the citric acid cycle overflow for the insulin and leptin signaling means, which in turn dictates the thyroid signaling, means that all of the nutrients involved in ATP production in the citric acid cycle are important. And that includes every single B vitamin, all the electrolytes, so sodium, potassium, calcium, magnesium, phosphate, bicarbonate, and then it includes iron, copper, molybdenum, and sulfur. And so literally any nutrient deficiency could compromise these hormones. And what about the 1,451 inborn errors of metabolism that create impairments in these pathways that might need to be addressed nutritionally, but not in the way of don't be deficient in riboflavin, but in the way that maybe your metabolism only works with 400 milligrams of riboflavin, which you can't get from food. So in how I found my health super unlock after 20 years of research and 20,000 genes tested, which is a previous episode, I estimated that each person is carrying 1 to 6 mutations that are nutritionally actionable in ways that go completely outside of maintaining normal nutritional status and create specific impairments in energy metabolism when unoptimized that can be fixed with the right optimization that are thousands of times more important than the rest of their 14 million sites of polymorphism. Okay, so how to approach hormones? This is what I believe is the right way to view this, right? Putting aside the importance of managing mindset, spiritual orientation, and social connections, putting aside the topic of menopause that I'm saving for another day, and putting aside the tumors that could alter your hormones that might require surgery or other medical treatments, I'm not a doctor, I am offering the following as a sensible approach to hormone problems. So first of all, certainly the lowest hanging fruit is optimizing body composition. I know that losing weight, which is, some people need to gain weight, losing weight or gaining weight, eat less food, eat more food, sounds easier than done for many people. I would say experiment with different approaches based on shifting macros. Don't be dogmatic about it. Maybe you need low carb, maybe you need high carb, low fat, maybe you need high protein, maybe you need low protein. So experiment to find what melts the fat off your waist seamlessly. Counting calories, fad diets, whatever seems to work. If you find something that works and leads to relatively effortless or completely effortless normalization of your body composition, do it and get there. If the obesity or overweight proves intractable, I think that calls for a more sophisticated approach that really outlines what I'm about to say for hormones, but I'm going to specifically address it next week. So there's also nothing wrong with just going to randomized controlled trials and say, well, these things have worked for this, so let's try it in a kind of trial and error approach. But again, don't be dogmatic about it. So because you are not the group average. The trials are showing the group average, but you're an individual, so it might not work for you. But for example, in humans or animals, there are studies suggesting vitamins A and D, the MK4 form of vitamin K2, iron and boron might raise testosterone. MK7 or inositol is helpful for polycystic ovarian syndrome. And there's also nothing wrong with using isolated nutritional tests like plasma selenium or serum iodine to see if a specific nutrient that relates to a specific thyroid condition needs correction. I do think testing is especially important for selenium because some people are just too high in selenium and shouldn't be supplementing with it. It's not as important for iodine, but you might be surprised at the variability in how much iodine it takes to get anyone's iodine levels normal. So testing is very helpful. But when such low-hanging fruit doesn't do the trick, I think what you need to do is you need to start running comprehensive nutritional screening and using my Testing Nutritional Status, the Ultimate Cheat Sheet, to correct any deficiencies that are found. So you can go to the link in the description, follow it through to get to the article that this video and podcast is based on, and you can go to the lab testing section of the menu, and you can find comprehensive nutritional screening, and you can also find comprehensive screening for energy metabolism, and then you can also find the cheat sheet under ebooks. And if this doesn't normalize the hormones, I think that the next step is to run comprehensive screening for energy metabolism impairments, because if your body composition is all set, if your mindset stress level is properly managed, and you're not deficient or toxic in any nutrients, then you can give up and just take the hormones. But I really think that the clear next step is figuring out, okay, the data say that I've got a handful of impairments in my energy metabolism that might need optimization way beyond what normalizing nutritional status would suggest. And so let's figure out what they are and fix the bottlenecks. So the goals of a good approach to hormones, in my view, should be, number one, supply the body with the raw materials needed to make the correct hormones. Number two, supply the body with the raw materials to make the signals that you need to regulate those hormones. And then number three, to give the brain the right reasons to believe that energy is abundant. And that includes maintaining healthy body composition, maintaining good stress management, and removing any bottlenecks in energy metabolism by optimizing any actionable genetic impairments in the metabolic pathways. So did this change your mind about the proper way to view hormones? Let me know in the comments, and check out the link in the description for the article version of this that includes all of the references.